Okay, so good afternoon, class. We are going to talk about polynomial expression this afternoon. Actually, this is just a review of your previous lessons in junior high school polynomial expressions. You'll notice that there is no equal sign because this is just an expression, a mathematical phrase. For this polynomial expression, I'm going to denote this with p of x, because our variable here is x. X, 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 x. Okay, let's begin. Now, a polynomial expression p of x is an expression of the form a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus, you can also say a sub n minus 2 times x to the power of n minus 2 plus, you continue this pattern until you reach a sub 1 times x plus a sub 0. Our exponents here, I'm talking about the exponents of the variables, are arranged in descending order. If we say descending order, it is from the highest exponent, which is our n, highest exponent. And we call this degree, to the lowest exponent. Okay, so from n, it will be n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, and so on until you reach 1 and 0. So where is 0 now? Actually, beside a sub 0, we have x to the power of 0. Okay, these are the exponents. But remember that any number or any variable raised to the power of 0, it will always be equal to 1. For example, x to the power of 0, this is just 1. So if I'm going to substitute 1 to x sub 0 here, it will just be a sub 0 times 1, which is just a sub 0. Okay, so I can erase this part, since this is just 1. There you go. We also have to remember that these exponents are non-negative. Non-negative. All exponents must be positive. Exponents must be positive. No negative exponents at all. No exponents that are in fraction form. Okay, next. We also have to remember that not just the exponents, but also the coefficients. Our coefficients are a sub n minus 1, a sub n minus 2, until you reach a sub 1 and a sub 0. These are real numbers. Coefficients are real numbers. Okay, so it's okay if they're going to be negative, positive, as long as they're real numbers. And the terms of the polynomial may be written in any order. But in this case, since we have already arranged the exponents in descending order, we call this polynomial expression as a standard form. Standard form. Alright, and aside from that, your a sub n, this part, must not be equal to 0. A sub n is not equal to 0. I will give you more examples in the next video. These are some of the examples of polynomial expression. Okay, first we can have 2x plus 1. Actually, this is just a binomial because there are two terms. The first term is 2x and the second term is 1. There is no negative exponent in our variable x, and our numerical coefficient 2 is a real number. So this is a polynomial expression. Another example will be x cubed plus 2x squared minus 7. Both number 1 and 2 are in standard form because our exponents are arranged in descending order. You will see here that the exponent is 3, the exponent is 2, and the exponent here of our x is 0. Because remember what I said earlier, any variable or any number raised to the power of 0 will just be equal to 1. So 7 or negative 7 times 1 is just negative 7. It's okay if, for example, there is no x to the power of 1 here, or just a variable x, because there is no such rule wherein polynomial expressions, all variables are in descending order with complete exponents like 3, 2, 1, 0. It can be 3, 0 or 3, 2, 0, or it can just be 1, just like in example number 1. Okay, next example, we have x square root of 2. Is this a polynomial expression? Yeah, you can actually write this as 2 square root, sorry, again. This is square root of 2 x. Okay, just interchange x and square root of 2. That's okay because this is multiplication. Square root of 2 is also a real number. And your x here has an exponent of 1, which is also positive. Number 1 is a binomial, number 2 is trinomial, and number 3 is a monomial. There is only one term in example number 3, but this is still a polynomial expression. Okay, how about number 4? Number 4, we have 2x cubed minus 3x squared plus x minus 4. In this case, this polynomial expression is, let's say, complete because the exponents are really in descending order. You have 3, 2, 1, and x to the power of 0. But there is no need to write x to the power of 0 because this is just equal to 1. I'm just showing you that the exponents are complete. So I can just erase this part. If the exponent of your variable is 0 beside a number, it means this one is your constant. This one is your constant. I'm going to write constant. Remember, that's your a sub 0. Okay. And then we can also have a polynomial expression of this form. X plus 5, multiply this binomial to the square of 9x plus 1, and multiply that to x minus 4. This polynomial expression is in factored form. This is a factor, another factor, and another factor. If you're going to multiply everything, you can actually arrange the terms in descending order and you will get the standard form of this polynomial expression. Okay, to discuss about the degree is the highest exponent. Okay, what is the degree in example number 1? What is the highest exponent? 1, right? So the degree here is 1. How about in number 2? Okay, that's 3. The degree is 3. In example number 3, the degree is still 1. Alright, sorry. The degree is 1. In example number 4, I'll just erase this part. Okay, minus 4. The degree here is 3. Okay, how about if this is in factored form? Do I have to multiply everything just to find the degree? Okay, you don't have to do that. If you're just looking for the degree, just try to analyze this part. Here, you have an exponent of 2 outside the binomial 9x plus 1. So, it is expected if you're going to expand this, the highest exponent enclosed to this 2 parentheses will be 2. If you're going to multiply x squared to another x, it will be x cubed. And to another x, it will be x to the power of 4. Therefore, the degree here is 4. You have 1, you have 2, and another 1. 1, 2, 3, 4. The degree is 4. Okay. Now, these are some of the examples of expressions that are not polynomials. 2 over x plus 1. This is not a polynomial expression because a polynomial expression should not have a variable in the denominator. If the variable is in the denominator, then this is not a polynomial expression. Another example, x to the power of negative 3 plus 2x squared minus 7. This is also not a polynomial expression because the exponent is negative. The variables are okay, but one of the exponents of variable x is negative 3. So still, this is not a polynomial expression. Number 3. 2 square root of x. If I'm going to rewrite this in exponential form, this square root of x, that will be 2 times x to the power of 1/2. In a polynomial expression, the exponent should not be fractional. Therefore, this is not a polynomial expression. Okay, take a look at example number 4. 2x cubed minus 3x to the power of 1/2 plus x minus 4. Why do you think that this is not a polynomial expression? Okay, because one of the exponents is a fraction, just like in example number 3. How about example number 5? I have here the binomial x plus 5 multiply to the binomial 9x plus 1, but 9x plus 1 have an exponent of negative 2. All of this will be divided by x minus 4. Why do you think that this is not a polynomial expression? Okay, correct. Because there is a negative exponent and there is a variable in the denominator. So remember, expressions that are not polynomials have negative exponents. Fractional exponents, and of course there is a variable in the denominator. Okay. These are some of the reasons why the examples are not polynomials. Activity 1. Spot the difference. These are the answers for the activity. Number 1, letter B. 2 over x plus 1. This is not a polynomial expression because the variable is in the denominator. Number 2, x to the power of negative 3 plus 2x squared minus 7. This is not a polynomial expression because there is a negative exponent. Number 3, 2 square root of x. This is not a polynomial expression because the exponent is fractional. Number 4, A. 2x cubed minus 3x to the power of 1/2 plus x minus 4 because the exponent is fractional. Number 5, B. X plus 5 times the negative square of 9x plus 1 all over x minus 4. This is not a polynomial expression because there is a negative exponent and the variable is in the denominator.